Hello children, we're going to be nerds for today.
And we're going to teach you about parts of a similar triangle.
So I will show you some vocabulary on parts of a similar triangle. Proportional. Two things correspond in sides or angles with each other. Altitudes. A segment with a point from one angle to the opposite side perpendicular. Similar triangles. Triangles that have proportional side lengths and angles. Bisector. A segment that evenly splits an angle in two equal angles. Median. When a segment goes from the midpoint of a side of a triangle to the opposite angle, making two congruent lines. Congruent. Sides and angles of a polygon that have the same scale factor. So now we will go over some similar triangle theorems.
There are 4 theorems that involve parts of a similar triangle. The first one states that
if two triangles are similar, the lengths of corresponding altitudes are proportional to the lengths of corresponding sides.
The abbreviation for this theorem is similar triangles have corresponding angles proportional to corresponding sides. This problem down here states that triangle ABC is similar to triangle EFG. This states that then the altitude AD over the altitude FJ is equal to the proportion of the side AB to FJ. The next theorem states that
if two triangles are similar, the length of corresponding angle bisectors are proportional to the lengths of corresponding sides.
The abbreviation is similar triangles have corresponding angle bisectors proportional to corresponding sides. These two triangles show down here that if KLM is similar to triangle QRS, then the bisector LP is proportionate to bisector RT is equal to the proportion of side LM to RS. The next theorem states that
if two triangles are similar, then the lengths of corresponding medians are proportional to the lengths of corresponding sides.
The abbreviation is similar triangles have corresponding medians proportional to corresponding sides. This triangle here shows that if triangle ABC is similar to EFG, then the proportion of the median CD and HG is equal to the proportion of AB over EF. The last theorem states that
an angle bisector in a triangle separates the opposite side into two segments that are proportional to the lengths of the other two sides.
With this triangle, it shows that this angle bisector created two separate triangles. This shows that when you take this side, KM, and set it to proportion with LM, it is equal to the proportion of KJ to LJ. We will be using this last theorem to show a real-world example using one of the Lenape computers. Using this computer screen, we cut it in half to create one triangle, then created 2 more using an angle bisector. Using the theorem that we last used, it stated that the proportion of this length over this length is equal to the sides of the triangle, this one and this one. Using this theorem, we will find the missing angle of this side. Setting up the proportion, 12.25 over 7 equal to 17.5 over x, x being the missing side. Then you will cross multiply these two and these two to get 12.25x equals 122.5. After that, you will divide each side by 12.25. The answer after that is x. And that is the answer for the missing side. And that's the end of our video.
And now you know what you need to know.
Good luck in geometry.